Good afternoon to all of you scientists out there. Thank you for joining me on this Monday afternoon for another installment of our AIM Science Experiments. I'm Dr. Karen Joseph, and I'm a science teacher at Deborah Bell's AIM Academy. And I teach a couple classes I'd like to tell you about. I teach a semester-long zoology class that starts in January, as well as two science mini courses that also start in January. One is called The Wonders of Water, where we learn all about the amazing properties of water that make it so unique and make it really special for life on Earth. And the second class that I teach, the mini course, is called Sensational Senses. And we learn all about all of our senses and how we experience the world. And you may wonder what a mini course is. A mini course is a 7-week course that is really a great introduction to online learning. If you're not sure if you or your child would enjoy online learning, mini courses are a really great introduction, so you can get an idea of what an online course is like and whether it works for you. So again, registration is open. Those courses start in January, as well as all the other AIM courses, science and social studies and English and lots of other subjects. So I encourage you to go to deborahbell.com and take a look. So thanks again for joining me. Today we're going to do some more fun experiments. We had so much fun with the candy experiments that we did last week that I thought it might be fun to do a few more experiments this week. Now, one of the experiments that I actually had some questions about, both from people who watched the video live and from some people who experienced it after, was whether or not Skittles would do the same thing that M&Ms do. So I thought that might be fun to do an experiment to see whether Skittles or M&Ms dissolve faster. So let's do that experiment and see. But before we start, like any good science experiment, we always want to start with a hypothesis. And we talked about hypothesis a couple weeks ago. A hypothesis is, you can think of it as like an educated prediction. So you have an idea of what's going to happen. We already know what's going to happen with M&Ms, and because we saw that last week, the candy coating dissolves off the M&M. And we know that there's also a candy coating on Skittles. So you make a hypothesis to see what you think is going to happen. What do you think is going to happen when we pour water on M&Ms and Skittles at the same time? Is one of them going to dissolve faster? Are they both going to dissolve at the same time? Are neither of them going to dissolve at all? Make your hypothesis and then we'll get started. So I'm going to tip my camera down so that you can see the experiment in action. So what we have here, I have two bowls and I have M&Ms in one. You can see the M's on this one here, and I have Skittles in this one. Notice I'm using the same colors so that we have the same kind of experiment going. We want to control the variables so we don't change as many things, any more things than we absolutely have to. So the next thing I'm going to do, I have a couple of flasks here. Now these are called Erlenmeyer flasks, and these are great special science equipment. They're pretty cool, but you could just use a glass or a measuring cup. Each of these Erlenmeyer flasks has about 1/4 of a cup of water in it. For those of you who use metrics, that's about 60 milliliters of water. And I'm going to pour water in these at the same time, and we're going to watch and see how they dissolve. Are you ready? Here we go. They moved around a little bit. So I'm going to just take my finger and move them so that they're kind of spread out a little bit, because that'll make it a little bit more dramatic. And we're going to watch. Now this water is just about room temperature. That means it's not cold and it's not warm. It is room temperature. So you can already see the dissolving beginning. The orange ones are dissolving and the brown ones are dissolving. Don't see a lot of dissolving on either one of them in the green. Do you think one of them is dissolving faster than the other? Doesn't look like it to me. Maybe the Skittles are winning just a little bit. The Skittles are here and these are the M&Ms. The Skittles look like they might be a little bit ahead, but only just a little. They're dissolving pretty well. So the next thing that you can do to experiment with these is leave it a little bit longer. Look again here. I want to point out how the colors are not really blending. Do you remember that from last time? The different colors melt off, they dissolve away and they get into the water like that, but they don't blend because there's already color in that side and it won't diffuse as well because there's already those molecules. So while we're watching these for just a minute, I want to talk about why things dissolve. So I'll leave the camera down, but I'm also going to reach on top. So this is a little molecule that I have, a little model of a water molecule. Water molecules are made of 2 hydrogens. That would be these sort of green marshmallows. And this would be 1 oxygen. So a water molecule is H2O. That means it has 2 hydrogens and 1 oxygen. And each of these atoms that is in this has a little bit of a charge on it. That's because atoms all have electrons zooming around the outside of them. And those atoms, those electrons have a negative charge. Now, since the electrons spend more time in a water molecule circling around the outside of the oxygen than they do outside the hydrogen, the oxygen has a slightly negative charge. And the hydrogens have a slightly positive charge. So what happens when we have something that dissolves is that the charges attract other things. So let's talk about the candy. The candy coating on the candy molecules also has 1 positively charged and 1 negatively charged end. When you have the positive end of a water molecule come into contact with the negative end of a candy molecule, they attract one another. And the water molecules pull on that negative end of the candy and actually pull it apart. They break it apart. So if we had, let's pretend like this is another molecule, and let's say this is candy. And when these 2 attract one another, they actually pull one another apart like that. So the water pulls apart the candy molecule, and that's what you see happening in the water. Now, we're going to take a look here again at these 2 that we have here. You can see that the M&Ms have dissolved all the coating away, and we're left with just that white coating that's at the bottom. But we've also got some dissolving that's happening here. Water is such a good dissolver that we call it the universal solvent because it dissolves so many things. So I want to show you something here too. I set this up before so that you would be able to take a look at this experiment. Let me see if I can zoom in here. So can you see here how the M&Ms, this is the one that has the M&Ms, all the color is down there, but look what's happening with the Skittles. We can not only see color, we can also see white around the outside of the Skittles. That's been sitting there for about 10 minutes. And if I left this one sit for about 10 minutes, we would notice exactly the same thing happening. So why is that? Why do we have white dissolving off of the Skittles? Well, the Skittles are candy all the way through. The Skittles are, let me see if I can get that. There we go. The Skittles are candy all the way through, where the M&Ms are chocolate. And chocolate does not dissolve quite as readily as the candy that the Skittles are made of. So that's why if we leave that longer, and I encourage you to do this when you do it at home, leave it for about 15 or 20 minutes, and you'll see all the water, all the white part of the candy that's dissolving, and it'll actually push the color away just a little bit so you'll be able to see. Let's take one quick look at that again before we move on. So this is the chocolate one here, and this is the Skittles one here, and you can see that white, and it is a beautiful color, isn't it? Okay, so now let's do another experiment. I'm going to move this one aside. Let me clean this up. Science is kind of messy, you guys. You got to be ready to do some dishes when you do science, don't you? But that's all right. So our next experiment that we're going to do is going to use cotton candy. And this is actually a really good time of year because you can find cotton candy in a lot of stores like Walmart's and Kmart's because people use it at Christmas time. So all you need is some kind of cotton candy, and we need a bowl, and we need some water. So I'm going to tip the camera down again so that you can get a bird's eye view. Bird's eye view is what we call it when you're looking at something from the top. So I'm going to take some water, and I'm going to fill my clear bowl with water. All right, great. And then we're going to take some cotton candy, and we're going to watch what happens. Now, again, form a hypothesis. I've got some cotton candy here. I pulled it right out of this cotton candy container. Pulled it right out of there. So what do you think is going to happen when I drop that cotton candy in? Let's actually grab here Let me see here if I can get something with some color, because I think that would make it a lot nicer to see. So let's slide this nice pink piece of paper under there so that you can see. So to make your hypothesis, what's going to happen when I drop the cotton candy into the water? You ready? It's gone. It just vanished. The cotton candy dissolved so quickly. Now this is really fun. So let's do that a couple more times. Are you ready to watch again? Watch what happens when we drop the cotton candy into the water. It's completely gone. There's no cotton candy left in there at all. That looks like just water. We can see a little tiny bit of sugar in the bottom there if you look really closely. And let's do one more time. And then we're going to do another thing with cotton candy. Ready? One more time. Drop it in. Vanishes. Isn't that fun? It's beautiful. So let's talk about why that happens while I set up the next part of the experiment. So the next thing I'm going to do here is put some cotton candy on this plate. And I'm going to spread it out a little bit. The reason that cotton candy dissolves like that is because when cotton candy is made, the way that it's made is they spin the sugar. They make the sugar really hot, and then they spin it in a special machine that makes it into very, very thin strands. That means that more of the surface of the candy, of the sugar, is available. So we say that it has an increased surface area. So I've got a lot of cotton candy laying here, and all this is surface area, as opposed to if I took some of the cotton candy and squeezed it down really tight. You can see that. If I squeeze that, look how small I can make that. That doesn't have nearly as much surface area as this has here. So the next thing I'm going to do is I'm going to use a dropper. I'm going to use a regular eyedropper, and I'm going to see what happens when I put some drops on the cotton candy. I don't know if you guys can, oh, look at that. It's dissolving away. Isn't that fun? Now imagine if you could have several different colors of cotton candy. It's just dissolving away on the plate. Wow, look at that. One more time, let's do that. So how could we extend this experiment? What are some things that you could do to make this experiment a little bit more detailed? One thing that you could do is you could try different colors of cotton candy. Do you think different colors would make a difference? What about if you took a cotton candy and instead of just dropping it in loose like this, what if you made it into a really tight ball? And then you tried to drop that in there. Now, what you know about cotton candy is that part of the reason it dissolves so quickly is because it has a bigger surface area. We're making a smaller surface area here. So what do you think? Form your hypothesis and then make your cotton candy into a little ball and drop it in your water and see what would happen. Cotton candy is really a lot of fun to play with. And it's also a lot of fun to eat. You probably noticed that as soon as you put that piece of cotton candy into your mouth, it dissolves. That's because all that surface area comes into contact with the water, which is called saliva, that's inside your mouth, and it vanishes in exactly the same way it did when we dropped it into the water. Very cool. All right, I've got one more experiment to do, and this experiment uses Pop Rocks. Are you familiar with Pop Rocks? When you put them in your mouth, they kind of make a popping sound. Well, let's do a little experiment with them and see. Now, for this one, I'm going to need to put on safety goggles because we're going to have some flying Pop Rocks. So we always want to use science safety whenever we're doing any kind of science experiments. So here I've got a little bowl that is called a mortar and a pestle. So the bowl part here is called the pestle, and this is called the mortar. And we're going to crush up our Pop Rocks. So what we're going to do here is we're going to pour the Pop Rocks down into the bowl. And I'm going to hold this up so you can see this. There we go. And I want you to try to listen. I'm going to hold it real close to the camera so that you can listen. I'm barely pushing. You can't really tell. When you do this at home, you'll notice that you don't have to put much pressure on that at all. And it makes all kinds of cracking sounds. Now let's try pouring it into a bowl of water. And I'm going to put this down here. We're going to put the Pop Rocks down into a bowl, and then we're going to add some water, and you're going to listen. You ready? You hear that sizzling and crackling sound? I'm going to fill that up. And I'm going to raise this up so that you can see the bubbles that are coming up from the Pop Rocks. You'll be able to see this a lot better when you're doing it at home. There's a lot of bubbles coming up from the top. So the reason this happens is because when they're making Pop Rocks, now I'm all done with the crushing part, so I can take off my safety goggles. If you're doing the crushing, when you push down on that, some of the Pop Rocks pop out. So always make sure that you've got some safety goggles on when you're doing that part. But what happens with Pop Rocks is when they're making the candy, they blow carbon dioxide into the hot syrup that they use to make the candy. And then as it cools, it cracks and it comes into pieces. And that's what you get when you have a package of Pop Rocks. You get these tiny pieces. Let me pour them into the bowl again so that you can see. Now, this is another color. But see how we've got these little pieces of Pop Rocks here? Yeah. And when I press down on it with the, with the stick there, I can listen to the sound again. There. Yep. All right. So the next thing we're going to do then is we're going to look at this here. And you can still hear the sound. What do you think? Should we pour in a few more Pop Rocks and see what happens? Can you hear that crackling sound? That happens because when we break open or dissolve away the candy, the Pop Rocks release the carbon dioxide that's trapped inside. And that carbon dioxide comes out and it makes a crackling sound. So what we get when we put Pop Rocks in our mouth is dissolving candy. Remember what dissolving is. It's water pulling apart the molecules because of the negative and positive ends. And then when the water molecules have pulled apart the candy, the carbon dioxide is released and we're able to get that really fun crackling sound and crackling feel that you get in your mouth when you eat Pop Rocks.